Hello mathematicians, we're going to do some questions on vectors, which is the main focus of the next chapter. A lot of you have seen some of these already from physics, but in mechanics we'll do them a little bit more in detail, and so once you've done this chapter on the book, you'll find the physics questions comparatively much easier. So let's do the first example. You probably find this one relatively straightforward, but it's no harm in going over it. So first example. It says forces P and Q. I'm going to write them down. P is a vector and Q is also a vector. Forces P and Q act on a particle at the origin O. So let me draw an origin. Origin O, and they act on the particle which is at the origin O, that's the particle, along the coordinates OX and OY respectively. So that means that this coordinate here would be OX and this is OY, and it says respectively, meaning that the first force P acts along OX and the second force Q acts along OY. And then they give us, they tell us calculate the magnitude of the resultant force and the angle it makes with the x-axis, and they give us different options for the sizes, the relative sizes of P and Q. In the first one that we want to do, well, I'll only do one of these examples, but in the example that we're going to do, they give us 8 newtons for P and 5 newtons for Q. So if P goes along the OX with a size of 8 newtons, so that's my P, vector P, and it's got a magnitude of 8, and Q goes along the OY, that's Q, with a magnitude of 5. Then when I want to add these two vectors, I need to do heads to tails, so I need to shift this guy over there, and it would look like well, let me use another color. When I shift it over here, it will look like this, in the same direction as it had when it was here, so they're both parallel. And so then my resultant would be what joins my initial head, my initial tail to my final head. That would be my resultant. I'm going to call it R, and that's also a vector. If that's 5, then this guy here is also 5. It's the same thing, and these are two sides of a rectangle, right? So if I want to calculate R, then I just need to do a Pythagoras triangle formula. So then my R squared would be equal to 5 squared plus 8 squared. So R would be the root of 25 plus 64, and that would be 89. And 89 square rooted comes out to be square root of 89. In the calculator, that's 9.43, and a bunch of other numbers, but we're going to leave it like that for now. We only needed to 3 significant figures, so we would say 3 newtons for R, right? And now we want the angle theta, which they also ask us for. So we've got instead of using R here, we should use the numbers that they've given us in the question, so then we don't make any mistakes of approximation and rounding and things like that. So let's use that triangle to find theta. We're going to use SOHCAHTOA. SOHCAHTOA, as always, when we want to find an angle in a Pythagoras triangle, in a right angle triangle. And what do we have? The opposite, and this is the angle, and this is the adjacent. So opposite and adjacent are these two. So we want the tan. So tan of the angle that we're interested in is equal to the opposite divided by the adjacent, so that's 5/8. And so if we want to find theta, we need to take the inverse tan of both sides, which looks like this. And that on the calculator is just shift of tan. So the angle comes out to be shift of tan, brackets, don't forget the brackets, so 5 divided by 8, close brackets, is equal to nearly exactly 32 degrees. So that's the two parts of the question, and that's finished. Now let's do a slightly harder example that should be quite familiar to you from the work we've done so far, and let's do a second example. The second example, it says two forces, again they're called P and Q, so that's my P and that's Q, act on a particle at the origin O. So I'm going to draw an axis here, that's my particle, that's the origin. Force P acts along OX, so again force P acts along OX, and this is OX here, and this is OY. So force P acts along OX, but force Q doesn't any longer act along OY, and now acts at an angle theta to OX, so force Q is going to be somewhere over here, and at an angle theta. So they're going to give us the theta and Q, and they're going to give us the P, and then we're going to find out the resultant with these two vectors, which are not at 90 degrees anymore. So we're going to make we're going to end up with a parallelogram instead of a right angle triangle. So we're going to have to use trigonometry, which is a little bit more tricky than this SOHCAHTOA over here. Okay, so they tell us that P is 3 newtons and Q is 4 newtons. So P goes along here, that's P, and it has a size of 3. And Q is 4 newtons, but it's at an angle of 60 degrees. So if this is 30 more or less, this is 45 halfway through, then 60 is going to be quite going up like that. And that's going to be Q. And it has a size of 4, and we need to add it to this 3 here to find out the resultant. So once again we shift this guy over there and we keep the direction so that he looks like something like that. That's not very good. I keep deleting the 4 by mistake. Something like that. And so that's also 4, and it's also Q, and we want to find out this guy here, from the tail of the first one to the head of the second one. That's our resultant. We want to find out this guy here, and we are told this angle, which is 60 degrees, but we're not told this is 60 degrees, but we're not told the angle of that R makes, so we need to find out what the angle of R is. Now let's do a little bit of geometry to find out some other angle in this triangle. Since we don't know what this angle here is, we've got to do some work to at least find out other angles. And from here, it looks like the easiest one to find is going to be this one here. Since this line here is parallel to that one, then if this angle there is 60 degrees, then that angle there is also going to be 60 degrees. So if that's 60 degrees, then this whole thing here, which is a whole flat line, is 180. So if that's 180 and that's 60, that's going to be 120 here, 120 degrees. So now we've got this side and that side and the angle in between, which is 120, which I've written down really badly. So whenever we have two sides like that, and we have the angle in between, the best thing to use, it's specially built for these types of questions, is called the cosine rule, or the rule of cosines. Cosine rule. And it says that a squared is equal to b squared plus c squared minus 2bc cos a. So hopefully you've seen this before. And the triangle, the type of triangle that this is useful for is whenever we have one angle here, for example, and we are interested in that angle, and we have this side here, which would be B, and this would be C, and that would be side A, and this angle there, we call it always opposite to the side, so that would be A. So we have little a, big A, little b, and little c. And it looks like quite a big C, but that should be a little c. So in our formula, A, B, and C are the things we use, and then big A. And here we have R would be what we're interested in. This would be our R there. Would be the same as our A. And the opposite angle, big A, would be 120, and then B and C would be 3 and 4. You can take them in any order, 4 and 3, 3 and 4. It doesn't really matter here. So let's write down the in terms of this what we have. We have R squared, which is what we want, is equal to the B squared plus C squared, either one of those first. So that's 3 squared plus 4 squared minus 2 times B times C, doesn't matter which way, and then cos of the angle, and the angle is 120. So if I chuck all of this in the calculator, well, this simplifies a little bit to 9 plus 16, which is the same thing as 25, minus 2 times 3 times 4, which is 6. 6 times 4 is 24, times cos of 120. So R is going to equal the square root of that, and that comes out to be, let's see, 24 cos 120, 24 times cos of 120. Make sure it's in degree mode. It's minus 12. So this is minus 12, and that's minus, so it's 25 minus minus 12. Minus and a minus is the same thing as a plus. So 25 plus 12 is 37. So this is the square root of 37 is the magnitude of R. Okay, and the square root of 37 is equal to 6.08, but 0.08 newtons. But this is an exact answer, so if we need to use that number again, it's better to use root 37. To 3 significant figures, that's 6.08. Let's see if that makes sense given what we have. Something 3 and 4, and they're at that angle, so then something that is 6 for the hypotenuse. That makes sense. It's not too far out. It would be 20, it would be a bit worrying. It would be 1, it would be impossible. So 6 sounds about right. So that's good. We only have 2 minutes and a half left, but I'm gonna just outline the next part, and then in the next video we'll actually do it. Now we need to find out this angle here. We're being asked for the direction also, so we haven't quite finished. We just got R, and now we need the angle. So let's make the triangle here again. That's our triangle, something like that. And we're interested in this angle here, which we're going to call theta. We know this is root 37, and we know this is 3, and we know that's 4. And this is 120 degrees. Okay, so with that information, we now have opposite angles. We have one angle and the opposite side, and one angle that we're interested in, and we know the opposite side. So whenever you have that situation where you have opposites like that, then you use your rule of sines. So we'll talk about the rule of sines in the next video, and then we'll continue from there with the next example. See you in the next video.